Transformers are manufactured to be step-up or step-down transformers, and these are used to increase or decrease the voltage simply by using a different number of turns within the coil on the secondary side. In a step-up transformer, the voltage is increased in the secondary coil, and this will mean that the current will decrease. But don't worry too much right now about why that occurs. We'll look at this in a later electrical engineering video. To increase the voltage in a step-up transformer, we just need to add more turns to the coil on the secondary side than the primary side. In a step-down transformer, the voltage is decreased in the secondary coil, which means that the current increases. To do this, we just use less turns in the coil on the secondary side compared to the primary side. For example, a power station needs to transport the electricity it has generated over to a city some distance away. The power station will use a step-up transformer to increase the voltage and reduce the current, as this will reduce the losses through the long transmission cables. Then, once it reaches the city, this will need to be reduced to make it safe and usable by buildings and homes, so there will need to be a step-down transformer. The transformers for commercial buildings and power stations are usually in a three-phase configuration. You'll see these placed around your cities and towns, and they'll look something like this. These three-phase transformers can be made from either three separate transformers that are wired together, or they can be built into one large unit with a shared iron core. In this setup, the coils will typically sit concentrically within one another, with the higher voltage coil on the outside and the lower voltage coil sitting on the inside. Now, these coils are insulated from one another so that only the magnetic field will pass between the two coils. To connect the two sides, there are many different configurations, but one of the most commonly used is to connect the coils in a configuration known as delta Y, sometimes referred to as delta star. This refers to the primary side being wired in a delta configuration and the secondary side being wired in a Y configuration. The center point of the Y side, where all three connectors meet, is often grounded, which allows for a neutral line to also be connected.